Hello everybody and welcome back to my YouTube channel. As you read in the title, this is the British Physics Olympiad 2020 Paper 2 Question 1A. And basically, this page doesn't really tell you much about the question. However, these two are the important questions, and basically we're trying to find the value of k. We'll read the question on the next page. Here's how the question goes, and we'll be highlighting the important information as we go through. For a modest temperature range, a sample of a metal in the form of a cube of side L0 and volume V0, we don't really need to write that, I've written that information down here in the graphic, is heated by delta T. So like a difference of temperature. For a small temperature changes, its volume expands by a temperature-dependent factor such that V is equal to V0 1 plus gamma delta T, where, this looks very much like a simple interest formula. And so does this equation, which represents the length as it expands linearly by a factor which is expressed by this particular equation. If the expansion factors are both small, so this is actually going to be important, and we know that gamma is equal to some constant times alpha, where k is a numerical factor, derive a value for k. So we know that k is a numerical factor, so from this we can take two hints, right? We can take the fact that we are going to have to approximate, or we're going to have to give an answer as a function. So of course, because they want a value for k and we want to derive a numerical factor, we're going to try to approximate. So first of all, we have a cube with lengths L0 and volume V0. And after applying temperature, heat expands objects, and because a cube is proportional and symmetrical in all directions, this heat expansion translates into the cube expanding equally in all directions, which would mean that this L0 will transform into L by some constant linear factor as expressed by this particular equation, and this change in length will cause a change in the volume as expressed by this equation right here. Now again, these are all small values and for small temperature changes. So again, it's all about approximating everything. Next thing we want to do is basically we want to identify two very important relationships, and we will like to be using the fact that we know that this is a cube, right? A cube is a very simple, arguably one of the most simple three-dimensional shapes. It has a very interesting property in the sense that its volume is just its length cubed. Now, using this information, we know very clearly that L cubed must equal V, and this is the new cube, this is the expanded cube. And for the first cube, we have the relationship that L0 cubed is equal to V0. Now, basically what we can start doing is implement this particular equation into this relationship. So let's actually do that right over here. So we know that V0 to 1 plus gamma delta T is equal to L0 is we're going to cube everything on this side of the equation. So we're going to be left with the equation that V0 into 1 plus gamma delta T. Okay, now that we have the simplification, we can refer back to this particular identity and divide both sides by L0 cubed, right? L0 cubed. L0 cubed. Now, since we know this term and this term are equal, we can use this to cancel these out, and we're left with the simple equation. Now, there are formulas for expanding a binomial cube, which is a plus b to the power 3, but I just like to use the thing called the Pascal's triangle and the binomial theorem to do this expansion. So basically what I'm going to do is I'm just going to expand 1 plus alpha delta t. I'm pretty sure if you're watching this video you know how to do this, so I'm just going to, not really focus on this aspect of the solution. Please excuse my handwriting, that is actually meant to be alpha delta t cubed. Okay. Anyway, next set of simplifications, we can subtract 1 from both sides. So now we're left with the identity that... Now basically we have this particular equation, and we are going to be manipulating for k. Now remember, we know that from this particular thing, we know that gamma is equal to k alpha. What does that mean? That means that k is in turn equal to gamma over alpha. And that is basically what we're trying to find here. We're trying to find gamma over alpha. That's something which we can easily do using this equation. Now, I have written the equation down over here. We have canceled these aspects out. So basically what we can do is we're going to start to factorize this side of the equation. So here what I'm going to do is we know gamma delta t is the same thing as alpha delta t. And I'm going to take this common factor. So this goes here plus. Now here you can see that we can perform similar simplifications to delta t, and we're left with an expression for actually k. We're left with gamma over alpha, which is equal to k, which is what we want. It's equal to 3. Now the important thing we need to realize here is the simple fact that we know that all these three constants alongside delta t are very, very small. And we're basically gonna use that fact, and apparently this is a very commonly used trick in physics, is because we know alpha, gamma, and delta t. Well, gamma is really irrelevant here from this equation, are both extremely less than 1. And therefore, if they're really less than 1, or this translates to 10 to the, I think, -2. So basically, this sign means that they are less by a factor of 100, at least. I believe that's what this sign stands for. Anyway, because we know that they're really small and delta t are what we call modest temperature changes, we can let alpha delta t equal to 0. So what this would do is it would give us a numerical approximation for the value of k, and as you probably would have guessed, this gets eliminated, this gets eliminated. So we're left with the simple answer, k is equal to 3. And that is the answer to the first question on the British Physics Olympiad 2020 round 2. Thank you very much for watching. Like and subscribe if you like this video. This is a new format of video. If you want to see more solutions like these, please leave a comment down below. Thank you very much.